Hello, my dear students. Welcome to our chemistry basic series. Okay, in this class, we are going to see about the basics of organic chemistry. You see, there are three main branches of chemistry at the school level. The one is inorganic chemistry, second one is organic chemistry, the third one is physical chemistry. Among these three, the easiest part of chemistry is organic. Sir, what you are telling is organic is so tough for me. Actually, I can't understand organic. It is always confusing me. Like that you may feel, but it is not at all true. Okay, if you understand the organic, then it will be very, very easy. Okay, it is actually one of the easiest part of chemistry. But you should not read organic chemistry. You should not study organic chemistry. But you should play with organic chemistry. Shall we play with organic chemistry? Okay? Yes. So to play, actually organic chemistry is a playground. So we all have to play with it. Okay? So to play, first we must know about the basic things very clearly and very strongly. Okay? Right. So first, actually what is organic chemistry? Organic. The spelling of organic, O-R-G-A-N-I-C. Okay, without C, there is no organic. Without C, you see, just C, without C, there is no organic. So, organic is the chemistry of C. C stands for carbon. So, organic chemistry is the chemistry of carbon. That is a very fundamental thing you have to first know. Okay, right. So it is the chemistry of carbon. Okay, so nothing. In this class, actually, we are going to see the fundamental things you must to know or to understand organic very clearly. Okay, okay. Let us start the class. So first of all, we see about hydrocarbons. 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 The name itself says what? Hydrocarbons are consisting of only hydro means what? Hydrogen and carbon. So the organic compounds. If the compound contains carbon means generally it is called as an organic compound. So the organic compounds containing carbon and hydrogen only are called as what? Hydrocarbons. Okay. In general, hydrocarbons are classified into many types. The first most important classification is alkanes. What? Alkanes. The next one is alkenes. The next one is what? Alkenes. The next we can write alkynes. Alkanes, alkenes, alkynes. Okay. And these are all coming under aliphatic part. These are all coming under what? Aliphatic. One more classification, we can see what? Aromatic hydrocarbons. Aromatic, aroma means what? Smell. Okay. So in organic chemistry, some compounds may be aliphatic and some other may be aromatic. Aromatic compounds are said to be aromatic on the basis of some rules. So it should be what? Cyclic, planar, and it should have 4n plus 2 pi electrons. These are all together called as Huckel's rule. It must satisfy Huckel's rule. We will see about Huckel's rule and aromatic nature in the latter part of our class. Okay, right. In this class, we are going to see only about the fundamental things. So, in general, hydrocarbons are classified into two major types, aliphatic and aromatic. Aliphatic can be further into alkanes, alkenes, and alkynes. Okay, but these are all coming under the heading hydrocarbons. And alkanes are containing only what? Carbon and hydrogen. Because they are coming under hydrocarbons. The general molecular formula for alkanes is CnH2n plus 2. CnH2n plus 2. Okay. And for alkenes, the general molecular formula is CnH2n. Alkenes CnH2n. And for alkynes, CnH2n minus 2. CnH2n minus 2. First, let us finish about all this. Okay. Later, we will see about what? Aromatic. Okay, ma? Right. So, alkanes. The general molecular formula for alkanes is what? CnH2n. You see, all these three alkanes, alkenes, and alkynes contain only carbon and hydrogen. CH, CH, CH. So, these are all coming under hydrocarbons. So, these are otherwise called as hydrocarbons. Okay. So, let us see about alkanes. So, in this molecular formula, if you give the value for n as 1, you get what? C1 and H2n plus 2. H2n plus 2. 2 into 1, 2, 2 plus 2, 4. So C1H4. It is simply written as CH4. It is simply written as what? CH4. Okay. If you give the value for n as 2, you get what? C2H6. C2H6. If you give the value for n as 3, you will get what? C3. 2 into 3, 6 plus 2, 8. C3H8. If you give value for n as 4, then you get what? C4. 2 into 4, 8 plus 2, 10. So C4H10. And value for n as 5, you get what? C5H12. So like this it goes on. Okay, so CH4, C2H6, C3H8, C4H10, C5H12. So these are all what? Actually alkanes. These are all what? Alkanes. Okay. Okay. So before continuing alkenes and alkenes, let us finish alkanes first. Okay. We will see these two later. Okay. Right. So we are focusing only on alkanes now. Okay. Right. Fine. So alkanes are the compounds having molecular formula CnH2n plus 2. CnH2n plus 2. So CnH2n plus 2, isn't it? Okay, fine. Right. Actually, let us give the names for these alkanes. Alkanes. The name Alkane. Alkane. If the compounds satisfying or consisting of this molecular formula in general are called as what? Alkanes. So CH4 is an alkane. CH6 is an alkane. This is also alkane. All these are what? Alkanes. If the alkane containing only one carbon, then the name it should contain is, the root word it should contain is meth. So this is actually the root word. The root word. If the organic compound, any organic compound contains only one carbon, is the name should contain meth, M-E-T-H, meth or meth as the root word. If it contains two carbons, means it should contain, the root word is eth or eth, eth or eth. If it contains three, means prop. What? Prop. So 1 meth, 2 eth, 3 means prop. If it contains 4 carbons, means but. The root word is what? But. If it contains 5 carbons, means the root word is pent. What? Pent. Then 6 means eggs. 6 means what? Eggs. 7 carbons means hept. 7 carbons means what? Hept. 7 means hept. 8 carbons means oct. 8 carbons means what? Act. Acta. Acta means 8. Okay, octopus. The actually animal which has what? 8 legs or 8 hands, we can say. Okay, so it is octopus. So acta means 8. 9 means what? Non. In Tamil it is what? Nava means 9. Navaratri, 9 nights. Okay, so Nava means 9. So like that, non. 10 carbons. If the compound contains 10 carbons, then the root word is deca. What is that? Deca. Actually, decade. Have you heard about decade? Decade. So decade is nothing but 10 years. It is the collection of 10 years. So 10 years time period is otherwise called as what? Decade. So deca means what? 10. So if the compound contains 10 carbons, means the root word is deca. Okay. So dasa, you can correlate with dasa. Dasa means 10. Deca means also what? 10. Okay. So 11. If it contains 11 carbons, then it is undeck. So here we can simply write what? Deck, not deca, deck. So here 11C means undeck. Okay, so deck, undeck. If it contains 12 carbons, means what? Dodeck. 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 Do means here 2. Okay, so 12 means dodeck. 13 means trideck. Okay, tri, tetra. So actually, di or bi. Di or bi means what? 2. 2. Tri means what? 3. Tetra means what? 4. Okay, so penta means what? 5. Hexa means what? 6. Okay, in some ways we can represent number 2 as di or bi. 3 means tri. 4 means tetra. Okay, so trideck means 13. Tetradeck means 14. Like that it goes on. So if it contains 20 carbons, 20 means ecosa. 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 Ecosa deck. Ecosa deck. Okay, right. So like this it goes on. So up to 12, you just keep in your mind. It is most important to understand the organic chemistry very well. Okay, right. So the root word is very, very important to understand the names of the organic compounds. Okay. So first let us continue. So first one is, if you give the value for n as 1. If you give the value of n as the 1, you get what? CH4. CH4. If you give value of the n as 2, you get what? C2H6. 3 means C3H8, like that. Okay. CH4. Actually, in organic chemistry, the valency of carbon is what? 4. The valency of carbon is what? 4. Carbon can form 4 bonds around it. Carbon can form 4 bonds around it. So the valency of carbon is always 4. The 4 bonds can be 4 single bonds. Okay. Otherwise double bond. Otherwise 1 double bond, 2 single bonds. Otherwise 1 triple bond and 1 single bond. Anything it may be. But in all the organic compounds, the valency of carbon should be 4. It must satisfy the valency as 4. Like that, the valency of nitrogen, generally it is 3. Whenever nitrogen has 3 bonds or 3 valencies around it, it will have 1 lone pair of electrons. Like that, for oxygen, the valency is 2. Valency is 2. So always oxygen will have 2 bonds around it. Carbon will have 4 bonds around it. Nitrogen will have 3 bonds. Like that, oxygen will have 2 bonds. Whenever oxygen has 2 bonds around it, it will have 2 lone pairs of electrons around it. And for hydrogen, the valency is always 1. So 1, 2, 3, 4. 1 hydrogen, 2 oxygen, 3 nitrogen, and 4 carbon. Isn't it? So these valencies actually fundamentally you should keep in your mind very strongly. Okay, right. So the first alkane, if you give the value for n as 1, then you get CH4. Okay, now let us write the name of this alkane. Okay, first let us write the structure. We know that carbon should have 4 bonds around it, and it is CH4 has what? 4 hydrogen atoms, and for hydrogen the valence is 1. So hydrogen should have only 1 bond. Okay, so around 1 carbon we should write 4 bonds. These 4 bonds are connected with 4 hydrogen atoms. So this structure is now expanded like this. These both are same, identical. You can write CH4 or like this, isn't it? Okay, fine. Let us write the name of this compound. Since it contains only 1 carbon, the root word is meth or meth. Since it satisfies the general molecular formula CnH10 plus 2, it must be an alkane. It must be an alkane. So alkane means the name should end with what? Ane. This alk is meth and the name should end with ane. So its name is what? Methane. Methane. Meth plus N, methane. So the organic compound or the hydrocarbon having CH4 as the molecular formula is called as what? Methane. Right? Okay. Like that, let us give the value for N as 2. We get the molecular formula C2H6. So let us expand the structure C bond to C. Since it has two carbons, carbon is bonded with carbon. You see, carbon has one more unique property, that catenation. It is called as what? Catenation. Catenation is nothing but the self-linking property of carbon. Carbon can link with any number of carbons. So number of carbon atoms can be joined together through bonds, through covalent bonds. Okay. This self-linking property of carbon is called as what? Catenation. Okay. Carbon can bond with any number of carbon. It goes on in a straight manner or branched manner, like that it goes on. Okay. So this self-linking property of carbon is called as what? Catenation. Right. Okay. That's why if it has two carbons, then carbon is bonded with another carbon. But however, in all the cases, carbon should have 4 bonds around it. So in this case, C2H6 has 6 hydrogen atoms totally. So bond, 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 bond. These are all bonds. 6 hydrogen atoms. So 1, 2, 3, 4, 5, 6. So we can fill like this. Okay. So now C2H6 is expanded like this. Like this. Okay. What should be the name? What will be the name we should give? Actually, it has 2 carbons. So the root word is what? Eth. Since it satisfies the molecular formula CnH10 plus 2, it must be an alkane. So eth plus ane, ethane. Eth plus ane, what? Ethane. Okay, right. So like that, propane also we can N is 3. Now N is 3. I write here N is 3. If N is 3, we get what? C3H8. C3H8. Okay. So C bond C bond C. Bond, 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 bond. Here H, here bond H, bond H, bond H, bond H, bond H, bond H, bond H. Okay. You see, now I can simplify this. C3H8 can be written like this. I can simplify, now this is what? Very large, I can simplify this. This carbon has 3 hydrogens along with it. Now I can write this as CH3. Now this one bond. This middle carbon has only 2 hydrogen atoms. Now I can write this as what? CH2. What? CH2. This last carbon also, like that of first carbon, it also has 3 hydrogen atoms. So bond CH3. So now this expanded structure can be written like this simply. CH3 bond CH2 bond CH2. CH3. Without bond, writing bond also I can write CH3, CH2, CH3. All are identical. Any form we can write. C3H8, 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 C3H8. Shall we give the name? Yes. Since it contains 3 carbon atoms, the root word is what? Prop. Since it satisfies the CnH10 plus 2, the name must contain ANG. So it is an alkane. So prop plus ane what? Propane. Prop plus ane what? Propane. Okay. So why can't we write this ethane also in shrinked form like this? Okay. Yes, we can write. You see C, 3 hydrogen atoms. So CH3. Bond C, 3 hydrogen atoms. CH3. Yes, you can write CH3 bond CH3. So between these 2C, without bond also can be write? Yes, without bond also you can write CH3, CH3 simply. That is also ethane. Okay, right? Okay. The next N is 4. Let us give N is 4. The value for N is 4. Value of N is 4. Then you get what? C4H10. C4H10. This C4, C bond C bond C bond C. You see, C. Self-linking property of carbon, which is called as catenation. So valence of carbon is 4. So this carbon has now 4 bonds. For these 2 bonds here, 2. So totally all the carbons separately will have 4 bonds around it. So remaining 10 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So C4H10, you can count. It has C4 and H10. Okay, simply this can be written like this, This C along with the three hydrogen atoms, how can we write? CH3. CH3. Okay, this C, two hydrogen atoms, bond what? CH2. This C, two hydrogen atoms, CH2. This C, last C with the three hydrogen atoms, CH3. So CH3, CH2, CH2, CH3. Okay, so here one more structure also we can write. Already I told carbon can bond with another carbon in so many ways. Okay, so either in the straight manner or in the branched manner. So any way. So here all the four carbons are in a straight manner. Okay, why can't we write three carbons only in the straight manner? One is in the branched manner. So like this also we can write simply. Okay, so directly I fill the hydrogen atoms here. You have to write hereafter like this. See, this carbon contains only one bond. For remaining three hydrogen atoms, so three bonds, I put three hydrogens. Here also only one bond, so H3. Only one bond means H3. The middle carbon has totally three bonds, so I write H here. So CH3, CH, bond CH3, bond CH3. You see, this structure also has 4 carbons totally and 10 hydrogen atoms. 3, 3, 3, 9 plus 1, 10. Okay. So, from C4H10 molecular formula, we can write two different structures. But the above three, NH3, NH2, NH1, these all three have only one structure. We can't write more than one. Okay, you see this propane also only one structure, CH3, CH2, CH3. You can write in branched manner also this propane, but all are identical. CH3, then CH2, then CH3, then CH3. So these all are identical. Okay, so in propane we can't write more than one structure, but in the case of C4H10 we can write two different structures. Shall we give the name? These two structures individually contain what? 4 carbons totally. So if the organic compound contains 4 carbons, means the root word is bute. The root word is what? Bute. So bute. So this carbon is bute. This compound is also bute. Both compounds root word is bute. All these two satisfy at CnH10 plus 2. So ane. So ane. So bute plus ane, butane. So butane, butane. But the same name should not be given to two different compounds. These are two different compounds. But so we should not give the same names. The names also should be different. Okay, that's why we are giving some other prefixes like this compound contains 4 carbons in the normal manner, in the straight chain manner. So normal, N we can say. N-butane. The first compound is called as what? N-butane. And the second compound is called as isobutane. What? Isobutane. Isobutane. Okay. So there are two butanes, N-butane and isobutane. Actually, the name iso means branched. Simply we can say what? Branched. Actually, iso specifies what? Means whenever CH is bonded with the two CH3 groups. Whenever CH comes and it is bonded with the two CH3, at least two CH3, then this part will have the name iso. This part will have the name iso. So CH3 bond CH bond CH3. Whenever this comes, the name will have iso. Okay, right. So 1 carbon alkane methane, 2 carbons ethane, 3 carbons propane, 4 carbons what? Butanes. There are 2 butanes, N-butane and isobutane. If N is equal to 4, we get 2 different types of butanes. What about N is equal to 5? What about N is equal to 5? Let us write. If N is equal to 5, we can write all the 5 carbons in the straight chain manner. C, 5C. And 4C in the straight chain manner and 1C at the branch. 1C at the branch. Like that, 3 carbons in the straight chain manner, 2 carbons at the branch at the middle. At the middle. So this is the carbon skeleton of this C5H12. What a carbon skeleton. Skeleton, okay. Now, according to the valency, we have to fill hydrogens. Okay, right. So, one bond means H3, two bonds means H2, two bonds means H2, two bonds means H2, one bond means H3. Here, H3, H2, H3, H3, middle, here H. Here, H3, 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 H3. Middle already has, it has four bonds totally, so no need to put hydrogen, so just C. So, if N is equal to 5, C5H12 will have three different structures. These are all what? Structures. Simply I can write. But all these have 5 carbons totally. So the root word is pent. The root word is what? Pent. The root word is what? Pent. The root word is what? Pent. But all are alkanes. So pentane, pentane, pentane. So these are three different structures, but name also should be what? Different, as I told already. So we have to give different names. So the first one, as you know already, if the 4 carbons are in a linear consecutive manner normally, then it is called as normal pentane. So the letter N hyphen. So N hyphen pentane. So N pentane. Okay. The middle compound, you can easily tell. Just now I have told, if the structure contains CH3 bond CH bond CH3, CH3, CH, CH3. You see, this side, this CH3 can be written here or here also. Here also. Both are identical. Okay. Can you see? C, 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 C. This. CH3, 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 CH2, CH. These two structures are identical. These two structures are identical. Okay, so what are the groups this compound has? The same groups also this compound having. Okay, right. So this is actually CH3, CH, CH3. So totally 5 carbons spent. So alkane, so pentane. So CH3, CH, CH3. If this comes, the name will have what? Iso. So this is actually isopentane. 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 And the last one is around 1 carbon there are 4 CH3. Around 1 carbon there are 4 CH3 groups. So this is neopentane. What pentane? Neo. Okay. So N-pentane, isopentane, neopentane. So there are 3 pentanes. There are 3 pentanes. There are 2 butanes. But there is only 1 methane, only 1 ethane, only 1 propane. But 2 butanes and 3 pentanes. These are all coming under what? Alkanes. Alkanes are coming under what? Hydrocarbons. If N is equal to 6, it goes on. So up to your NEET JEE level, for this class, this up to this enough. Okay. If anything is needed further in future, we will see later. Okay. Right. One more interesting thing. Alkanes we have seen here. Now we are going to see about. We are going to see about alkyl. Alkyl. What? Alkyl. Alkanes are hydrocarbons, but alkyls are nothing but groups. Alkyls are nothing but groups. So alkyl groups. How alkyl groups are coming means alkane minus hydrogen. If you take 1 hydrogen from alkane, you will get what? Alkyl groups. If alkyl groups are written as R, then alkanes will be written as R bond H. If you remove 1 hydrogen from R bond H, you will get what? R. After the removal of hydrogen, these alkyl groups are deficient of 1 bond. That's why that bond is written simply bond. So alkyl groups are generally represented as what? R bond. If you attach 1 hydrogen with R bond, then it is called as alkane. So alkane minus hydrogen, alkyl. Alkyls are nothing but groups. They are groups, not compounds. Okay, right. Let us see some alkyl groups. So CH4 is alkane. It is methane. If you remove 1 hydrogen from methane, you will get CH3 bond. You will get what? CH3 bond. CH3 bond is otherwise called as methyl. You see, alkane, alkyl. This alk is actually common for both. The only difference is an becomes YL. In alkanes, the an part becomes YL in alkyl part. So, if the alkane is methane and for CH3, we should write the name by replacing ANE by what? YL. ANE is replaced by YL. So, the name is methyl or methyl. So, CH3 is called as what? Methyl. Alkane, alkyl. Methane, methyl. Okay. The root word remains same. Okay. Like that, C2H6 is ethane. C2H6 is ethane. If you remove one nitrogen, you will get what? C2H5. We also remove one nitrogen from this type of structures also. CH3 bond CH3. If you remove one hydrogen, you will get what? CH3 bond CH2 bond. Or CH2 bond CH3. All are identical. All are identical. What will be the name of this alkyl group? Since it contains two carbons, the root word is what? Eth. But it is short of one hydrogen as that of ethane. Ethane has C2H6, this is C2H5. So this is alkane, this is alkyl. So the name will YL, ends with YL. The name ends with YL. So ethyl or ethyl. So CH3 is methyl or methyl. C2H5 is ethyl or ethyl. Ethyl. Isn't it? Okay, right? What about 3 carbons? What about 3 carbons? 3 carbons group. 3 carbons alkane is propane. We are going to remove hydrogen from propane. If you want to remove hydrogen from propane, you have 2 choices. You can remove from either corner, from this CH3 or from this CH3. Okay. If you remove one hydrogen from this CH3, you will get CH3 bond CH2 bond CH2 bond. If you remove from this CH3, CH2 bond CH2 bond CH3. Are they same or different? Are they same or different? They are same only. Okay. What are the groups this structure has? The same groups also this structure is having. So CH3, CH2, CH2. It is from left to right. This is right to left. Both are identical, not same. We should say what? Identical. It is that only. One and only. Okay. So this is one type of propane. Sir, you told actually 2 choices, no? Yes. One more choice. One more chance is we can remove one hydrogen from the middle carbon. This is CH2 from this CH2. Okay, so CH3, CH bond CH3. CH3, CH bond CH3. Or from the structure, if you remove one nitrogen means from middle carbon, this H2 will become what? H. So CH3, CH bond CH3. Are they same or different? Are they same or different? They are neither same nor different, they are identical. We should say what? Identical. The one and only. Okay. You see, what are the groups this structure has? CH3. Here also CH3. CH, CH, CH3, CH3. So both are identical. Okay. Right. So we can write like this or like this. Okay. Right. So this is one type of group. This is one type of group. So propane. From propane we can get 2 different alkyl groups. The names for these 2 groups. The first one, propane minus hydrogen, generally propyl. This is also propane minus hydrogen, propyl. Propane minus hydrogen, propyl. Okay. So it is C, C, C. Normally we are removing the one hydrogen from the end. Okay. So this is actually normal propyl. So N propyl. N propyl. This is actually isopropyl. Iso, word again comes. Isobutane we have seen. Isopentane also we have seen. Now isopropyl group we are seeing. You see CH3, CH, CH3. Whenever iso word comes, there should be one CH group. That CH group must be attached with 2 methyl groups. Now I say this CH3 as what? Methyl groups. CH3 is what? Methyl. So CH should be attached with 2 methyl groups. Okay, so CH3, CH, CH3, the structure, if it comes, then the name will have iso. Total it has 3 carbons, so prop. It is one short of one hydrogen as that of propane. So it is an alkyl, so the name ends with YL. So isopropyl, there is only one propane, but there are two propyl groups. Only one propane, there are two propyl groups, N-propyl and isopropyl. You should not say simply propyl. Whenever you write propyl, you should not write simply propyl, it is wrong. You should write either N-propyl or isopropyl, then only it will be correct. It is okay. That shows that you are strong in organic. Don't write simply propyl. You show your potential by writing N-propyl or isopropyl. But only one propane. But there are two propyls, N-propyl and isopropyl. Okay. Only one methane, only one methyl. One ethane, one ethyl. One propane, but there are two propyl groups, N-propyl and isopropyl. Okay, right. So up to 3 carbons, up to 3 hydrocarbons, 3 alkanes, we have seen their respective alkyl groups. Okay. Shall I erase this? Yes, I am erasing this because I am short of the place on the board. Okay, let us continue. If n is equal to 4, we have totally 2 butanes, N-butane and isobutane. First, we write N-butane. N-butane is what? CH3 bond CH2 bond CH2 bond CH3. What about isobutane? CH3 bond CH bond CH3 bond CH3. So whenever you are writing the structure like this, you have to write the bonds clearly. If you are writing the branch, means the branching point, it should be bonded between carbons. You should write the bonds always between carbons, not between hydrogens like this. Simply you should not write. Okay, you should write the bond between carbons. It is more important. That shows what? If you are writing the bonds between carbons, it shows what? You have understood carbon. That means you are understanding organic. That means, that shows you are enjoying organic. Okay. So this is N-butane, this is N-butane, this is what? Isobutane. N-butane, isobutane. Okay, right. Okay, now let us derive some alkyl groups from these two butanes. There are two butanes. Let us see the respective alkyl groups. From N-butane, we have two choices to get their respective alkyl groups. You can remove one hydrogen either from here or from here. You get what? CH3, CH2, CH2, CH2 bond. If you are removing one hydrogen from here also, this end also, CH2, 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 CH3. Are they same or different? Same. They are identical, not same, it is what? Identical. So CH3, CS, they are just reversed. The structure is reversed. This is from left to right, that is from right to left, like that we can say. So this is one type of butyl group. This is one type of butyl group. Butyl. Is there any other chance to remove one hydrogen from this N-butane? Yes, sir. We can remove from here or from here. If you remove from here, you get from here you get what? CH3, CH bond, CH2, CH3. If you remove from here, you get what? CH3, CH2, CH bond, CH3. Are they same or different? Neither same nor different, they are identical. These two are identical. What are the groups this structure has? The same, this also. Okay, CH3, CH, CH2, CH3. Okay. So this is also another butyl. This is also another butyl. So there are two different butyl groups derived from N-butane. What about isobutane? From isobutane also we can derive two different alkyl groups. We can remove one hydrogen either from here or from here. These three methyl groups are identical because these three are attached with the CH only. So these are identical. We can remove from anywhere. Okay, you see, I remove one hydrogen from here. Okay, so CH3, CH, CH3, CH2. Okay, if you remove from here, that is also the same. If you remove from here, that is also this one. So all these three are identical, not different. Okay, right. So this is also another butyl. This is also another butyl. Okay, right. What about another? Is there any possibility for another alkyl group from isobutane? Yes, sir. We can remove from this middle carbon. This hydrogen can be removed. If you remove this hydrogen, you get CH3 C bond. CH3 CH3. So middle hydrogen has been removed. Now we get the structure like this. This is also another butyl. You see, butyl. There are 4 different butyl groups from 2 different butanes, N-butanes and isobutanes. Okay, so being these 4 different, we have to give the names also different. That should be. As usual, the first one has C in a normal manner. At the end, the hydrogen was removed, so we can add now. Write what? N. It is N-butyl, normal butyl. Okay. I ask you one question. First one is normal butyl. Now, the next 3. So yeah, these 2 are identical. These 2 are identical. This different. Among these 3 butyl groups, which is iso? This is option A, option B, option C, option D. Which is iso? Iso means what? CH should have 2 methyl groups attached with it. So CH, no CH. CH has CH here. So CH has 2 methyl groups, CH3 attached with it. So this must be iso. So this is isobutyl. So first one was N-butyl. Now the third one is isobutyl. What about the second one? If CH is attached with the 2 CH3 group, then it is iso. And if CH is attached with the 2 different groups, 2 different alkyl groups. You see CH here, this side CH3 methyl group, this side what? CH3CH2. CH3CH2 is what? Ethyl group. If CH is attached with the 2 different methyl groups and one bond is there, then it should be written as secondary. What? Secondary. So in short form, I am writing SEC dot. So this is secondary butyl. Secondary in otherwise can be written as 2 degree. So 2 degree butyl. 2 degree butyl. Okay. So if CH is attached with the 2 different alkyl groups, then it is secondary. So it is 2 degree otherwise. So secondary butyl. So N-butyl, secondary butyl. This is what? Isobutyl. What about the last one? If CH is attached with the 2 different alkyl groups, it is secondary. If C is attached with the 3 different alkyl groups or same type of alkyl groups, if C is attached with the 3 alkyl groups, then it is called as tertiary. It is shortly written as tert. Like secondary, it is what? Tertiary. For secondary, we can otherwise write what? 2 degree. In the same way, for tertiary, we can otherwise write what? 3 degree. So it is tertiary butyl or 3 degree butyl. 3 degree tertiary, 2 degree secondary. And 1 degree it is primary. 1 degree it is primary. Generally, primary should not be mentioned in the names. Okay, the N-butyl is primary actually. CH2 bond, primary. Isobutyl is also primary. CH2 bond. And only 1 alkyl group totally. CH2 bond, only 1 alkyl group. This is N-propyl group with the CH2. Here, isopropyl group with the CH2. So CH2 with 1 alkyl group, primary. N-butyl and isobutyl groups are primary groups. Okay, right, fine. So there are 4 butyl groups: N-butyl, secondary butyl, isobutyl, tertiary butyl. In one time, a NEET exam asked which is among the following is the isobutyl group. Like that, the question was, one of the option contains CH, CH2 bond, CH3, CH3. One of the option, I think option B. Okay. So which is isobutyl group among the following? This is isobutyl group. Otherwise, you can write like this: CH3, CH3, 2 methyl groups along with the CH. Okay, so iso, totally 4 carbons but, it is short of 1 nitrogen from this parent hydrocarbon butane, so butyl, so isobutane, this is isobutane. Sorry. Okay, so understanding of organic is very, very important. If you understand well, then you can play well. Yes. Okay. Okay, so up to 4 carbons we have finished. So up to 4 carbons we have finished. Okay. What about 5 carbons? 4 carbons means we have 4 different alkyl groups. If 5 means you see how many alkyl groups will come. But only 3 alkanes from 5 carbons, N-pentane, isopentane, neopentane. Okay. In this we see only one type. Okay. There will be so many alkyl groups from pentanes, these 3 pentanes, but here you just remember we are just going to see only the alkyl group that is from neopentane. Neopentane. The last one is what? Neopentane. And if you remove one hydrogen from any of these methyl groups, so this C has 4 methyl groups around it, we can remove one hydrogen from any of these methyl groups, we can get CH3, CH2. I remove from here, so CH3, here CH2. Okay, this is neopentane. Actually, this is what will be? Neopentyl. Neopentyl. Okay, right. From isopentane also we can have different types of alkyl groups. If you remove one nitrogen from here, that is one alkyl group. If you remove from here, it is different. If you remove from here, it is different. If you remove from here, it is different. If you remove from here, that is also different. You see how many. And from N-pentane also, if you remove from here, it is one type. If you remove from this end, the same type. If you remove from the second position, either from here or from here, it is one type. If you remove from the middle, it is one type. So one type, second type, first type, second type, third type. So 3 different types of alkyl groups from N-pentane. Okay. If you want to see, we will see the latter part. Okay. So for this class, up to this enough. Okay. Okay. So we have finished alkanes. Alkanes up to carbon 5 along with their alkane. It is most important for the basic part of chemistry. Okay. So by finishing this now, let us enter into the next part of hydrocarbons, that is alkenes. 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 A-L-K-E-N-E-S. Alkenes. What is the general molecular formula for alkenes? CnH2n. CnH2n. Alkenes. Isn't it? If you give the value for n as 1, you get what? C1H CnH2n. 2 into 1, 2. So C1H2. That is what? CH2. There is no such a compound CH2. Okay. The valence of carbon in all the organic compounds, it must be 4, but this carbon has only 2 hydrogens. Okay. So this compound does not exist as a true compound, but this exists as a group. You see CH4, it is an hydrocarbon, very first alkane, it is methane. If you remove one hydrogen from methane, you get CH3 bond, and the name is what? Methyl. Okay, this is actually CH2, 2 sides bond. It is actually a group whose valencies are unsatisfied, unfilled. Okay, this is actually a group. This group alone, separately, it is called as methylene. Methane, methyl, methylene. But it is not a compound, it is just a group. The name of this group is what? Methylene. Methylene. Okay, right. If you give the value of n as 2, you get what? C2H4. So 2 carbons and 4 hydrogens. 2 carbons, C bond C we can write, and 4 hydrogens. 4 means for this carbon we can give 2 hydrogens. This also we can give 2 hydrogens. So C2H4. Is the valency satisfied for all the 2 carbons? No. Okay. For this carbon only 3 bonds are there. For this also only 3 bonds are there. So here one double bond is introduced. So CH2, this is otherwise written as what? CH2 double bond CH2. CH2 double bond CH2. Okay, right? Okay, so this is a complete compound. Okay, so C2H4, structure this, we can simply write CH2 double bond CH2. Okay, right, fine. And the name, what should be the name to be given? Means C2H6 alkane is ethane, C2H5 means ethyl. Okay, and C2H4 means ethylene. C2H4 means what? Ethylene. Like methane, methyl, methylene, ethane, ethyl, ethylene. C2H6 ethane, C2H5 ethyl, C2H4 ethylene, ethane, ethyl, ethylene. So it is the actually very first alkene, a very first alkene. Okay, so ethylene, CH2 double bond CH2. And the next one, if you give value of N as 3, you get what? C3H8, H2N. Sorry, C3H6, 23, 6, no? So C3H6. So 3 carbons, 1, 2, 3, 6 hydrogen atoms. Okay, so with this carbon, I write 3 hydrogens. With this carbon, I write 1 hydrogen. With this carbon, I write 2 hydrogen. So this carbon has totally 4. This carbon, middle carbon only 3. The last carbon here also, this carbon also only 3. So here double bond is introduced. So CH3, single bond, CH, double bond, CH2. So totally it has 3. So it is prop. Okay, so propane, propyl. So propyl. Since it is alkene, it is ene. Here also ethylene, ethylene. Here also propyl plus ene, propylene. Propylene. That alkene that has 3 carbon atoms is what? Propylene. And what about 4, sir? N is equal to 4. Yes, we can write N is equal to 4. If N is 4, you have this structure. You have the molecular formula C4, 4 into 2, 8. C4H8. 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 From the C4H8, I can write 3 different alkenes. C4, 1, 2, 3, 4. C4, 1, 2, 3, 4. C4, 1, 2, 3, 4. These are the carbon skeletons. Okay. Since they are coming under the formula CnH2n, they must have one double bond. So they are alkenes. Okay. I can introduce the double bond here, either here or in middle also. If I introduce here, it will be as the first one. If here double bond or here, both are identical positions. So this is one alkene, this is another type of alkene. This is actually branched, you can introduce anywhere. So I introduce here. So there are 3 different alkenes from C4H8. So this is CH3, 1 bond means 3 hydrogens, 2 bonds means 2 hydrogens, 3 bonds means 1 hydrogen, 2 bonds means 2 hydrogen atoms. 1 bond means H3, 3 bonds means H, 3 bonds means H, 1 bond means H3. 1 bond H3, 2 bonds H2, 1 bond H3. For this carbon, totally 4 already satisfied. Okay. So butane, butyl, then alkene means butyl ene. Alkene means butyl ene. Alkene means alkyl group plus ene. That is alkene. Actually, alkene, the name is what? Actually, alkyl group plus ene. Alkyl plus ene, alkene. So ethyl plus ene, ethylene. Propyl plus ene, propylene. Butyl plus ene, butylene. Are they identical? No, they are different. So the names also should be different. So in other alkyl groups we are given, in other compounds we are given N, iso, neo like that. But in alkenes we should not give like that because double bond is there. So actually the position of double bond, where double bond is located, that carbon is numbered as alpha. First carbon, next to alpha, beta, gamma, delta, alpha, beta, gamma, delta, omega, epsilon, like that it goes on. So alpha, beta, gamma, delta. So the double bond is between alpha and beta, means the first one, alpha, should be taken. So alpha, butylene. In this case, this is alpha, this is beta, this is gamma, and this is what? Delta. Here the double bond is between beta and gamma. So the first one, beta, is taken. So this is beta butylene. The first one was alpha butylene. The second one was beta butylene. Here you see, actually, we can give here what? It is branched. It is like that of CH, CH3, CH3. If it is CH, CH, CH3 means it is what? Iso. Since double bond is there, here H is not here. Okay, so that's why here also we can give the name what? Iso. Iso. So this is isobutylene. Okay, so ethylene, propylene, there are three butylenes: alpha butylene, beta butylene, and isobutylene. Okay, right? Okay. Sir, is there any group from any groups that can be derived from these alkenes? Sir, means yes, you can. Yes, we can. From ethylene, this is ethylene. If you remove one hydrogen from ethylene, you get CH2 double bond CH bond minus hydrogen. Okay, this group is called as vinyl group. This group is called as what? Vinyl group. Vinyl. This group is vinyl. Like that, from propylene also, we can remove one hydrogen from methyl. From where? From methyl, CH3. From methyl group, we are removing one hydrogen from propylene. Methyl means the CH3. From this CH3, if you remove one hydrogen, this is what? CH2 bond. Then CH. CH3 bond, CH2 bond, CH, double bond CH2. Otherwise, we can write what? CH2 double bond, CH bond, CH2 bond. Okay. So this group is actually allyl. This group is actually what? Allyl. A-L-L-Y-L. Allyl. Okay, right? Okay. Actually, we are putting this bond. So with this bond, some substituents may be attached. Some groups may be attached. Some halogens, some functional groups may be attached. If OH is attached here, then it is called as vinyl alcohol. If Cl is attached here, it is vinyl chloride. If Cl is attached here, it is called allyl alcohol. If OH is attached here, it is allyl alcohol. If Cl is allyl chloride, Cl is allyl chloride, OH is allyl alcohol. Like that we can write. Okay, right. That's why any groups may be attached here. That's why we are simply leaving as bond. Right. So these are all alkenes. From alkenes, the two most important groups derived are vinyl and allyl. You should keep this in your mind. Okay, fine. So up to this alkenes enough. Up to this alkenes enough. So next let us see about alkynes. What? Alkynes. 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 So actually alkynes are the organic compounds having carbon-carbon triple bond. So there will be a triple bond between two carbon atoms. Then those compounds are called as alkynes. Okay. So alkanes. Alkanes are having single bond. Alkenes are having double bond. Alkynes are having triple bond. Okay. Right. So what is the general molecular formula for alkynes? So CnH2n minus 2. CnH2n minus 2. If you give the values for n as 1, you will get what? C1H2n minus 2. 2 into 1, 2. 2 minus 2, 0. So hydrogen is 0. Then there is no such alkyne. Okay. So the minimum number should be 2. If you give value for n as 2, then you will get what? C2H, 2 into 2, 4. 4 minus 2, what? 2. So C2H2. So this is the simplest alkyne, which has actually 2 carbon atoms. So like alkenes also have, the starting alkyne also has 2 carbon atoms. Okay. So the very first alkyne is C2H2 and the very first alkene was C2H4, which was what? Ethylene, which is ethylene, isn't it? Okay. If you give the value for n as 3, you will get what? C3H 2 into 3, 6 minus 2, 4. So C3H4. C3H4. If you give the value for N as 4, you get what? C4H. 2 into 4, 8. 8 minus 2, 6. So C4H6. Okay, so up to 4 enough. Okay. So what will be the structures? C2H2. So C, there are 2 carbon atoms. So C bond C, I can write. So 2 hydrogen atoms. So H, the valency of carbon is 4 and the valency of hydrogen is 1. So what will be? So this hydrogen, okay, hydrogen carbon, only 2 bonds. So here what should be? A triple bond should be. A triple bond should be, isn't it? Okay, right. The next is C3H4. 3 carbon atoms, C bond, C bond, C. So carbon has the unique property of catenation, which is the self-linking of carbon atoms together, isn't it? Right. So C3H4, totally 4 hydrogen atoms. Okay. I give 3 hydrogens here. Now this carbon is satisfied. Okay. So I put triple bond here. Triple bond here. So whenever the molecular formula satisfy this general formula CnH2n minus 2, then those compounds definitely will have a triple bond in their structure. Okay, right. So for this carbon, totally 4 bonds. For this carbon, 1 hydrogen I can give. Okay, so this will be the structure, isn't it? And what about C4H6? C4, 1, 2, 3, 4. C4. Okay. 1 triple bond, isn't it? I can give triple bond here. Shall we write another structure? Instead of giving triple bond here, why can't I give here triple bond? Isn't it? Okay, right. So valency of carbon 4. So 1 bond means H3, 2 bonds means H2. For this carbon, totally 4 bonds satisfied, and for this carbon, 1 hydrogen. What about here? So CH3, 1 bond means CH3. For this carbon, totally 4 bonds satisfied. For this also, totally 4 bonds satisfied. For this carbon, 1 bond is already there. So I use H3. Okay. So this is one alkyne. This is another alkyne. These are different because the position of triple bond changes, isn't it? Right. Shall I give the names for this? Okay. What should be? In this case, if you give triple bond here, then you will get the same structure as that of first one. Okay, so this and this, these two are identical positions, isn't it? Right, okay, fine. Actually, this is actually called as acetylene. Acetylene. Okay, this compound is looking like acetylene, but instead of this hydrogen, this has one methyl group. So it is like that of acetylene with, instead of one hydrogen, one methyl group. So this is otherwise called as methyl acetylene. Methyl acetylene. Methyl acetylene. Okay. What about this? Instead of one hydrogen, this compound has what? One ethyl group. One ethyl group. Okay. What we do? So this is ethyl acetylene. Ethyl acetylene. What about this? Instead of 2 hydrogen atoms in acetylene, the last compound has 2 methyl groups. So methyl acetylene. So methyl means what? Dimethyl acetylene. Dimethyl acetylene. If 2 identical groups are there, means we should give what? The word di. Di stands for 2. In some cases, we will give bi also. Mono means actually 1. Bi or di. Di means what? 2. Bicycle. It has 2 wheels. So that's why it is called as bicycle. If the vehicle has 3 wheels, it is called as tricycle. Okay? Right. So tri means what? 3. Tetra means what? 4. Tetra means what? 4. For 5, penta. 6, hexa. Hepta, octa, nona. Okay? Nona. And deca. Okay? So 11, 12. If 20 means what? Icosa. What? Icosa. Not dec actually. That is icosa. Okay, fine. So alkynes. So acetylene, methylacetylene, ethylacetylene, dimethylacetylene, these are all some alkynes. Okay, right. If you remove one hydrogen from alkynes, you get their respective alkynyl group. Respective alkynyl group. So if you remove one hydrogen from acetylene, you get what? So actually, acetylene can be simply written as what? CH triple bond CH. CH triple bond CH, isn't it? Right. If you remove one hydrogen from one carbon, you get what? CH double bond C. This group is actually called as acetylene minus hydrogen, acetylynyl. Acetylyl, ACETYLYNYL, acetylynyl. Acetylynyl. Okay. Okay. But these groups are rarely coming in the reactions. Okay. So whenever they come, we will see in those areas later. Okay. Okay. So let us move to the next part of our class. So let us see about aromatic part. Let us see about our aromatic part. Actually, aromatic in organic chemistry, if you want to say one organic compound as aromatic, it should satisfy Huckel's rules. Okay, what are the rules and how to we have to find out the rules and how do we see the satisfaction of Huckel's rules? We'll see later. Okay, the simplest aromatic and very famous aromatic compound is benzene. Benzene. Okay, so our top now we are going to see about aromatic, isn't it? So benzene. The molecular formula for benzene is C6H6. C6H6. It has totally 6 carbons and 6 hydrogen atoms. Okay. So it is having cyclic. It is having the cyclic structure. 6 carbons. 1, 2, 3, 4, 5, 6. Okay. And 6 hydrogen also. So along with carbon atoms, it has 1 hydrogen. So actually it is 6CH. CH 6 times. So CH 6 times. Okay, so C6H6. The valency of carbon is what? 4. So here all the carbons have only 3 bonds around it. So we are putting double bond. If you put one double bond, it will be for both carbons. Okay, then here double bond, then here double bond. Okay, right. So this is the expanded structure of benzene. So why can't we put double bond here, sir, instead of here? Yes, that also you can put. That also you can write. C, 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 C. H, 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 H. Okay, instead of putting here, writing here, we can write here and here and here. So alternate positions have double bond. Right? These two are identical. So the position of double bonds will change due to resonance. So finally, we can write the structure of benzene as simply one cyclic ring, hexagonal cyclic ring with a circle in it. Okay. So this is the structure of benzene. Okay. So benzene simply C6H6 or this one. So benzene C6H6. Okay. So in benzene, all the 6 corners have 1 carbon and 1 hydrogen. Okay. Now, what will be the name of the group that is obtained after the removal of 1 hydrogen from benzene? Benzene is actually what? This is this one or this one. Okay. If you remove 1 hydrogen, from benzene, you get this one. Or we can write this as C6H5 bond. Okay. What is the name of this structure? This is actually called as phenyl. Phenyl. Benzene minus hydrogen is called as what? Phenyl, not benzene. Methane minus hydrogen, methyl. Ethane minus hydrogen, methyl or ethyl or ethyl. Methane minus hydrogen, methyl or methyl. Ethane minus hydrogen, ethyl or ethyl. Propane minus hydrogen, propyl. There are two propyl groups, N-propyl and isopropyl. Like that, butane minus hydrogen, 4 butyl groups. Okay. So here benzene minus hydrogen is not benzyl. It is what? Phenyl. So benzene minus hydrogen is not benzyl. It is what? Phenyl. Okay, right. Then what about benzyl, sir? Then what about benzyl? Benzene minus hydrogen, if not phenyl means, if not benzyl means, it is phenyl. If not benzyl means, then what is benzyl? Okay, let us see about benzyl. So this is benzene. This is benzene ring. In benzene ring, by replacing one hydrogen atom, let us see, this hydrogen atom is replaced by one methyl group. This group is what? Methyl group. Okay, this is actually methyl benzene or methyl benzene. If one hydrogen in benzene is replaced by methyl group, then it is called as what? Methyl benzene. Okay, we should write the name as methyl benzene, not as phenyl methane, not as what? Phenyl methane. Okay, this is phenyl group. Phenyl group is attached with this. Actually, this is CH4 is what? Methane. In methane, if you remove one hydrogen by phenyl group, can you write this as phenyl methane? No. Methyl benzene is correct. Phenyl methane is wrong. Why, sir? Means always the name should end with the larger part. Okay, so logically, larger part. Benzene has the smaller methyl group on it. The larger part benzene has the smaller part methyl on it. It is logically okay. Is there any logic here in phenyl methane? The smaller, so powerful, the smaller methane has the larger phenyl on it. Is it justified? Is it okay? The smaller methane part, methane group, methane has the larger phenyl on it. It is impossible. It is logically not okay. That's why the name always should end with the larger part, not with the smaller part. Okay, I can tell like this. You can place a cycle on a lorry. You can place a bicycle on a lorry. Can you place a lorry on a bicycle? Is it possible? No. So in the same way, the name methylbenzene is correct and phenyl methane is wrong. The one more famous name for this compound is toluene. What? Toluene. This is what? Toluene. So toluene is nothing but methylbenzene. If you place a methyl group on benzene, then it is called as what? Toluene. So toluene is nothing but benzene with methyl CH6H5 bond CH3. Okay. Now I ask you some questions. If this is toluene, then what about this? Orthotoluene? No. No. Then what about this? Metatoluene? No. Then what about this? Paratoluene? No. Then what about this? Sir, again orthotoluene? No. Then what about this? Sir, again metatoluene? No. Never. Okay. Then what are all these structures? All the structures are nothing but again toluene, the one and only toluene. These are all identical. Sir, what do you say, sir? What does it mean? That means if you replace one hydrogen by a substituent group, methyl or any other group, okay, if only one substituent is present on the benzene ring, it is attached with phenyl group, then you can place that group anywhere in the 6 corners. All are identical. I can't say all are same. All are identical. The one and only adhe. Okay, these all are identical. What is this? This is also toluene. Okay, this is in sleeping mode. This is in sleeping mode. So this all are toluene, 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 toluene. Okay, right? Okay. Right, sir, what about benzyl, sir? You told that benzyl already, no? So benzyl, what will be benzyl? Benzyl is nothing but if you remove one hydrogen from toluene, that is also from methyl group. That is also from methyl group. Then only it is called as benzyl. So this is benzyl. If you remove one hydrogen from methyl group of toluene, then it is called as benzyl. Okay, so this is benzyl. Benzyl otherwise can be written as C6H5CH2 bond. C6H5CH2 bond. So benzene minus hydrogen is not benzyl, it is phenyl. What about benzyl? Benzyl is nothing but toluene minus hydrogen. Toluene minus methyl hydrogen is called as benzyl. Okay, now you could have one doubt. Sir, like phenyl like phenyl in toluene, if you remove one hydrogen from benzene ring, if you remove one hydrogen not from methyl, from benzene ring, then what will be the name? You see, you are asking this question. Methyl group is as such. If you are removing one hydrogen from benzene ring directly in toluene, then what will be the name? This is called as toluene. This is called as what? Toluene. Toluene. Okay. If you remove one hydrogen not very next to this methyl group, but one carbon away from that is from here, then this is also toluene. If you remove one hydrogen just opposite to that methyl group, then what is the name? This is also toluene. All are toluene groups, but they are different. They can be simply called as toluene, but they are different actually because they are different in their structures, isn't it? Here, with this bond, any groups may come and attach. Some X group may come and attach, some halogens, some N-word group, some OH group, anything the group can be. Okay. What I finally want to say you is, if the angle between two groups in benzene ring is 60 degree, then it is called as orthotoluene. What? Orthotoluene. Orthotoluene. If the angle between two groups is 60 degree, that is adjacent actually. If the angle between two groups in benzene ring is 120 degree, then it is called as meta, M-E-T-A. So this is metatoluene. And if the angle between two groups in benzene ring is 180 degree, that means they are just opposite to each other, then the name is para. So to indicate ortho, we are putting simply O hyphen. So O hyphen toluene, that is orthotoluene. And for meta, M hyphen toluene, metatoluene. And para, small p hyphen toluene. Okay, all are small letters, small o, small m, and small p. Okay, ortho, meta, para. So there are three types of toluene groups: ortho, meta, and para. Okay, what about this? I write one more here. What about this? This is methyl group. I remove one hydrogen from this side. This side. This is also what? Toluene. This is also what? Toluene. Toluene, simply toluene means it is wrong. Whether it is ortho, meta, or para. Yes, it is also ortho. This is also ortho. Okay, because here also the angle between two adjacent groups is 60 degree. 60 degree. Okay, what about this one? This one. This is also what? Meta. This is also what? Meta. Because here also the angle between the two groups is 120 degree. 120 degree. Okay. So there are two ortho compounds. There are two ortho positions in benzene ring. Always ortho, meta, and para will come when if only one group is already attached. If only one group is present in the benzene ring, then there is no ortho, meta, and para. If already one group is present, now with respect to that group, Okay, another group is, if another group is present with 60 degree, then only ortho, then only it is called as ortho, then only ortho comes. Okay, if already one group is present, with respect to that group, if another group is present in 120 degree, then only it is called meta. So there are two ortho positions, this side, right side and left side. Okay, so there are two ortho positions, two meta positions, but what about para position? There is no two para positions. There are no two para positions, only one para. Okay, so already methyl group is there. With respect to that methyl group, only one para position. But there are two meta positions. There are two ortho positions. Okay, I think you are clear with ortho, meta and para, isn't it? Right, fine. So in aromatic part, you have seen about benzene and the phenyl group, toluene, benzyl, toluene and 3 tollyl groups. Okay, so these are very, very important fundamentally. If you know all this very well, then organic will work out within you. Organic will work out within you. Okay, right, fine. Now let us see about what? Next part is, let us see some cyclic compounds, cyclocompounds. Cyclic. Okay, so cycloalkanes. Cycloalkanes. Okay, the simplest cycloalkane which has 3 carbons is this one. So CH2, CH2, CH2. Actually, the molecular formula for this compound is C3H6. C3H6. Okay, C3H6 already we have seen, it comes under CnH2n minus, sorry, CnH2n, isn't it? C3H6. If you give the value for n as 3, then you get what? C3, 2 into 3, 6, C3H6. Already the CnH2n is the general molecular formula for what? Alkenes. Alkenes. So alkenes and cycloalkanes have the same molecular formula, isn't it? So this is having 3 carbons, so the root word is prop. Since it has only single bond between carbon atoms, it is ene, so propane. So the structure is, it looks like what? A cyclic compound. So that's why the name cyclo. So this is cyclopropane. Cyclopropane. Okay, right. So this is cyclopropane. What about this compound? C, 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 C. Valency of carbon is 4. So CH2, 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 CH2. Okay. So this is what? Cyclobutane. 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 What is its molecular formula? C4H8. Again, it comes under the general molecular formula CnH2n. So both alkenes and the cycloalkanes have same general molecular formula. So they must be isomers, isn't it? So okay. Let us see about later. Isomerism, let us see later. C4H8. This is cyclobutane. Okay. If the cyclic compound has 5 carbons. 5 carbons. C, 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 C. You see, all are C. CH2, 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 CH2. So totally 5 carbons. Now this cyclic compound is called as cyclopentane. Cyclopentane. Pentane means what? 5. Single bond. So N. Cyclic. So cyclo. So this is cyclopentane. Cyclopentane. Okay. And 6 carbons means 6 carbons. C, C, C. C, C, C. Okay. So CH2, 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 CH2. So this is cyclohexane. Cyclohexane. Isn't it? So up to 6, it is enough. So this is cyclopropane. Cyclopropane simply written as what? It looks like triangle. Triangle. So this compound is what? Cyclopropane. 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 This is cyclobutane. So simply a square, isn't it? So this is cyclobutane. Simply a square. This is simply a pentagonal. This is simply a pentagonal. So this is cyclopentane. This is cyclopentane. So like that, cyclohexane can be simply written as an hexagonal. So this is written like hexagonal. So this is cyclohexane. 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 If you remove one hydrogen from these cyclohexanes minus hydrogen becomes cycloalkyl. Alkanes minus hydrogen, alkyl. Like that, cycloalkanes minus hydrogen, cycloalkyl. So if you remove one hydrogen from cyclopropane, you get what? This is, I write on one here. So one hydrogen has been removed. So this structure is now called as cyclopropyl. So like that, from cyclobutane we can remove hydrogen from anywhere from these four corners. So this is cyclobutyl, cyclopentyl, like that. Cyclopentyl also we can remove from anywhere. So this is cyclopentyl. If you remove one hydrogen from cyclohexane from any of the 6 corners, then you get cyclohexyl. Okay. With these bonds, we can attach any groups. If you attach OH group is generally called as what? Alcohol. Okay. If OH group is attached to the cycloalkyl group, then it is cycloalkyl alcohols. If you attach one OH group here, OH, this is cyclopropyl alcohol. OH here, cyclobutyl alcohol, cyclopentyl alcohol, cyclohexyl alcohol. Okay. So the compounds. Instead of OH, if you attach any halogens like Cl, so cyclopropyl chloride. If here Cl, cyclobutyl chloride, cyclopentyl chloride, cyclohexyl chloride, like that it goes on. Okay, right? Okay. So for cyclic compounds also, we have seen about their fundamental parts. Okay. So by this we conclude this basics organic chemistry class. Okay. So repeatedly I am telling, organic is not a subject of studying, it is a subject of playing. It is the playing part of the chemistry. Okay, you have to play with organic. If you want to play with organic, you should be strong with. Okay. So continuously watching our classes regularly to build a strong chemistry within you. To build a strong and a very strong chemistry with fun and enthusiasm, you have to watch our classes regularly. Okay. So until then, bye.